What's up, people, and welcome to my tutorial in Pragmatic Data Science. So in the previous video we did feature scaling of our data set, and what that means is that we took the data, we kept the internal structure of how everything was put together, but instead of having a Fahrenheit scale here on the y-axis, we now have it on this floating point scale instead, where the value 1 is the maximum number that we have seen in the dataset so far, and 0 is the minimum value that we have seen so far, and everything in between is mapped to this scale instead. So it's the exact same thing, but we have this floating point scale instead of Fahrenheit, right? So the way our bad boy Gunner ice cream shop works is basically that on these top days here, when it's really warm and hot weather, people want to buy ice cream basically, and he can bring in maximum 10 people into the store, because then if he brings in more people it's gonna get too crowded, and he can basically only have maximum of 10 people helping him out in the store. So that means that on these spikes up here he needs to have 10 people helping him out basically. And on the low selling days, like when it's really cold here, maybe this day and this day, he can be there by himself, so he doesn't have to have anyone helping him out basically. So what we're going to do now is we're going to take a look at the little application that I built here, and we're going to see how he can use this tool and map from Fahrenheit to how many people is going to help him out. And what I did, I just copy pasted the code from the previous one for number 2 here, and I just added this section here in the end. So what this does is really straightforward. You can see how easy this is now. Now we have the normalized data here. So what happens here is we have this infinite loop that's going to loop until you quit with the Q, and then it's going to ask you how many Fahrenheit it is. And it's going to take the input from the CLI, and if the input is not Q, it's going to get the norm. We're going to use the normalize function that we had defined up here. You remember from the Wikipedia article. It's going to cast the choice to an int, and it is also going to give the min and the max temp that we have seen when we did the one pass here over the sorted data. So it's going to normalize your input the exact same way that we did with the other data, right? So this choice normalized here is going to be a floating point number between 0 and 1. And then what we do is we just multiply this by how many people he maximum can have in the sort, which is 10. And then of course we need to round this, because he can't like bring in 5.5 persons to help him out, right? So we need to round it to the closest integer, and this is how many people he should call in for the day, right? So let's test it out and see what it gives us. Alright, so it's going to ask how many Fahrenheit it is. Let's say that it is 78 Fahrenheit. And if it is 78 Fahrenheit, it needs to call in 8 people, because the score was 0.82. And we can test it out again. Let's try a little bit lower number. Let's say that it is 50. And then I need to call in 4 people, because the score was 0.44 something. Let's say that it is even less. Let's say that it is like, I don't know, 30. Oops, it's because I printed some stuff in the terminal there. Let's test it again. How many? 30. And then he needs to call in 2 people, right? So you can see that it is scaling according to the temperature, right? And of course I didn't validate the input here. If it's gonna crash if I give it something else, then I don't know, like a letter F is gonna crash or something, but it doesn't really matter. This is just a proof of concept how you would put something like this together, right? And hopefully it was clear to you now why we want to do this kind of feature scaling, because once we have the min and the max here, and once we have normalized the input that we get, it is really easy to get this score out here that we see in the terminal, the floating point score of how good the linear combination was, right? So at this point there is actually no there is no linear combination whatsoever, because we only have one item in our combination, which is the temperature. And in the coming videos, we're going to have a little bit of more dive into adding more features into this model and see why we want to normalize the data, and how we can really easily combine multiple features once we have it scaled. So that is the reason for why we want to have it scaled. So I hope it wasn't too confusing to you guys. If anything is unclear, just put it in the comment section. Take your time and test out the application so you see how this is put together, this new section here, so you understand what's going on here. Alright, so don't forget to subscribe if you haven't already, and I will see you in the next video. See ya, bye bye.